Hey everybody, I hope you're doing well. This is video 2 for the Implicit Differentiation series. So let me just jump right into it. I want to solve for dy dx. And I have a fairly complicated equation here. But it comes down to a little bit of algebra at the end that actually makes this more difficult than the calculus part. So let me run through this with you. I'm taking the derivative with respect to x. The derivative of y cubed, 3y squared, times dy dx. That's the chain rule there. The outside is the cubing, the inside is the y. Derivative of the outside, leave the inside alone, multiply by the derivative of the inside, which is dy over dx. That's the symbolic version of it. Now what about x times y? That's a product. I am going to take the derivative of the first, leave the second alone. Then add to that the first times the derivative of the second. The derivative of y symbolically is dy over dx. Plus the derivative of x, which is just 2x. It's the same rules that we had for the power rule. Equals dy dx plus, now don't get scared with sign of x, sign of y here. The derivative of sine is cosine. I'm going to leave the inside alone and then multiply this by the derivative of the inside, which is dy dx. So the goal of this question was to solve for dy dx. I have a dy dx in this term, this piece, and this piece. I want to bring all of those terms to the left-hand side. Well, 3y squared dy dx plus x dy dx minus dy dx minus cosine of y dy dx. Now what about the other terms? This one, and well, there are no others. I'm going to bring them to the right side. Minus y minus 2x. So I'm going to subtract y from both sides, subtract 2x from both sides, so I get negative y minus 2x. Now what's really nice about this left-hand side? Dy dx is in every single term. So I can factor out a dy dx out of each term. Most of this, actually all of these steps, this step and my final conclusion, this is an algebra step. Remember, that's a minus 1 when I pull out or factor out a dy dx. And that's equal to the right-hand side. Now, there's lots of ways to write these, but I'm just going to write it one way. So my final answer for this, dy dx, well, I have a numerator, which is negative y minus 2x, and I have a denominator, which I'm just going to recopy this. 3y squared plus x minus 1 minus cosine of y. And that is a slightly more complicated implicit differentiation problem. Remember, you still have the rules. Product rule, quotient rule, trig rule. Don't forget those when you're doing an implicit differentiation problem. After you go from the original equation to the derivative, the rest of it is solving for a single entity. It's solving for, in this case, dy dx. I hope you found this useful. If you have any questions, let me know. Have a great day. Bye.